Whenever you're ready.
Okay. Good afternoon. Today's presentation is called Further Adventures in QA for the Perl 5 core distribution. As compilers like GCC and CLang advance, they probe deeper for weaknesses in source code, generating additional build time warnings. These enable Perl 5 contributors to write more accurate and portable code. In this talk, we discuss tools we have written in the past year to identify such warnings. We also identify salient developments in QA for the core distribution over the past year. Over the previous 3 years, I've given a number of TPC presentations describing some of the efforts we've been making to ensure the quality of the Perl 5 core distribution. In 2017, I stressed the importance of smoke testing Perl on platforms other than Linux and of close analysis of situations where changes to Perl 5 bleed had an adverse impact on existing CPAN modules, the bleed break CPAN or BBC problem. In 2018, I discussed testing the so-called CPAN river against Perl 5 monthly development releases. The CPAN river being a subset of all of CPAN scheduled for installation in dependency order. In 2019, I introduced Multisection, a tool similar to Bisection used to determine multiple points in a software project's commit history where its test output changed and hence where bugs may have been introduced. My CPAN distribution devel-git multi-bisect implements this concept. This year, I'm going to talk about one modest extension to the concept of multisection, how to determine when a given build time warning first appeared in the development version of Perl. When you build Perl from source, you first run a shell script called configure, which probes your machine for its characteristics and which takes options you specify on the command line. It then writes a make file reflecting those characteristics and options. Among the options you can specify on configure's command line is the C compiler you will use to build the Perl executable. You then run make on particular targets specified in the make file to build the actual Perl executable. You'll then go on to call make test and perhaps make install, but those are beyond our scope for today. Today, our task is to analyze the warnings which your C compiler emits during the course of running make. Now, suppose that back on August 20th of last year, I wanted to build Perl from development version 5.31.3, which was released on that date. Suppose further that I was working on FreeBSD version 11 and wanted to compile with CLang, the default C compiler for FreeBSD, and specifically with CLang version 6.0, which on configure's command line is spelled -dcc equals CLang 60. It would be spelled somewhat differently on Linux. And suppose further that I wanted to capture the standard output and the standard error emitted by make and redirect it to a file. So I would write a program called something like run make for build warnings.pl, specifying the compiler and version and the commit at which I wish to run this program. Now, I'm sure any of you in the audience could write such a script in about 20 minutes, so I'm not going to go into its details now. They'll be available on my website at some point. For now, let's suppose that running this program concludes by pointing us to a file in which the output of make has been recorded. If we examine this file in an editor, we notice that build time warnings look like this. If we did this sort of thing often enough, we'd notice a pattern to how the build time warnings are composed. We'd notice colon delimited lines like this. The first thing reported is the name of the source code file that was being processed when the warning was generated, or at least the relative path to that source code file from whatever directory make it was currently in. In this case, encode.c. Next, the line number where the warning was generated, in this case, 1356. Next, the position within the line of the source code when the warning was generated, in this case, the fifth character in the line. Next, the string warning. And now the text of the warning, in this case, unused variable ix. And finally, the category the warning falls into. In this case, the category is unused variable. Now, the warnings category is actually the most interesting thing in this line. And that's because over time, C compilers evolve and introduce new categories of warnings. So if we were to build Perl at the very same commit, but with a more recent version of CLang, we might see additional warnings falling into newer categories. We could write a Perl script to tell us which warning categories were populated during a given build and how many instances of each category there were. So we wrote a script called report build warnings, and it takes a specific file in which we've reported the output of make. It reports that in this particular build, there were only 2 build time warnings emitted. Both were of the category unused variable. And I'll have more to say on the program report build warnings in a moment. Now, after reporting those warnings, we might want to inspect them in greater detail. So I've got another little program called parse build warnings that basically analyzes each warning and groups it into a Perl hash. At this point, you're probably wondering, is there a CPAN module for programs like this? And of course there is. It's called Perl 5 build warnings. Now, in the course of working on the Perl 5 core distribution, the Perl 5 porters are quite rigorous about making sure that the test suite runs without failures during make test. But we're not quite as rigorous about making sure that no new build time warnings have crept in while running make. Some build time warnings will only appear for the first time when we switch to a newer, pickier version of a C compiler, such as CLang, GCC, or G++. Nonetheless, when we do notice a new build time warning, we file a bug ticket about that, and here is an instance of that. Suppose that about 2 weeks after we analyze development version 531.3 for build time warnings, we repeated that process, but at a later commit, which I will simply describe as 9D. Run the same program, look for in this updated output file, and what do we find? That now we have new build time warnings, 6 of them, all of the category called deprecated declarations. We want to know, well, where did these occur? We run the parse build warnings program, and we see that all the instances of this new category deprecated declarations came from one source code file called interprovar.h. So we report this in a bug ticket. You can even go and look at the discussion of this in GitHub issue 17144. So we've picked up these new warnings. What do we do next? When a new build time warning appears, we need to rule out the possibility that this indicates a serious defect in our C-level source code. We want to determine the commit into our Git repository where the warning first appeared so that we can ask the author and or the committer of that commit to investigate further. As you might suspect, we apply the principle of bisection to this problem. Suppose that we wrote a Perl script to detect those points in a large series of commits where the set of warnings emitted during wake changed from the previous commit. We could then examine these transitions to identify the errant commit. Such a Perl script might be called like this. The program is called warnings transitions.pl. We provide it with a large number of command line options. Now, this, I'm sure you're looking at this and you're saying, wait, that's too much code. I can't absorb it. So let's just go to the next slide in which we look at the important command line switches for this program. There are four of them. We'll go through them in turn. First, last, compiler, and configure command. First, takes the full 48 character SHA of the last known good commit, which in our case was the tag Perl 531.3. Last is the SHA of a commit where we have detected new build time warnings. Compiler takes the compiler inversion. Again, this is a platform specific spelling which you find by the which command. I'll leave that detail later. And finally, the configure command is the full text of the configure command that you provide on a given system. I've trimmed that down for brevity and clarity. So your output will end up looking like this. You get something that tells you that the probable first instance of a given warning is at a particular commit, and you'll be directed to a file that has information on this commit. This file will contain a hash entry like this, transitions, and each transition is a hash with two keys, older and newer, and they point you to the location of the file on your system, the index number of this particular commit within the whole series of commits, and the MD5 hex of this file. So what we do is we look at the array of commits between first and last. We notice that there was a change in the set of warnings generated during make between index 75 and index 76. Well, we can diff the older and newer files in this case. And this is where and by examining that, we understand that we're looking at two commits right next to each other, and we're diffing them. And we find that the only difference is these new warnings. So therefore, we can be sure that this commit, which I'll simply call 57F, was the commit at which new build time warnings first appeared. We report this in our bug ticket, and we ask the author or committer to investigate and hopefully eliminate the build time warning. Now, once again, you're probably wondering, is there a CPAN module to do this? And of course there is. It's called devel get multi-bisect build transitions. It's the latest addition to the devel get multi-bisect distribution, which I spoke about at TPCNA 2019 in Pittsburgh. And the diagnostic program that I just illustrated, warnings transitions.pl, is included in the XT directory in that distribution. At this point, I'll pause and we'll take questions on what the matter that we've dealt with so far. And if time permits, I will then simply go on to name a number of other topics in QA for the core distribution, which I think are of interest and which people are free to discuss with me in other situations. Thank you. Todd?
Thank you, Jim. I do not see any hands up. If anybody has any questions, please raise your hand or just unmute and talk. Tim?
Yes, just by curiosity, are the Perl 5 portals?
I'm not.
Tim, we can barely hear you.
Can you hear me?
Very difficult to hear.
Can you hear me better?
That's a bit better.
Bit better. Just a question: are the Perl 5 porters using sanitizer? You mean about memory, libsan, and so on, libasan?
Yes, there are certain. We don't use it necessarily in a continuous integration manner, but certain of the contributors who know what address sanitizer does use it particularly in debugging.
Okay.
I make no claim to know that, so I won't say anything further about it.
Okay, thank you.
Other questions?
I can talk about address sanitizer.
If you want to say just a few words, Carl.
Yeah, just, I mean, we use it when we find a bug, but we also use it as a prophylactic. Right, you make some code changes, like Valgrind. We have that already in our make files. So if I make a big code change or before a release, I will make test Valgrind to make sure that we haven't added some out of address accesses, uninitialized things. And I will also build under clang with address sanitizer to look for undefined behaviors. Just before we release, I did that just before 532 came out to verify that we hadn't introduced something that we didn't know. So it's not just for debugging, but it's for, in a sense, it's for debugging, but it's
for QA.
Yeah, QA. That's right.
Yeah,
that's all.
Well, that's
Excuse me?
that's something where I am learning this for the first time because I've never actually run make Valgrind or anything like that.
But Perl is using memory arenas, thing like this. Carl?
Perl is using what?
Memory arenas.
Memory analysis. I'm not.
I think he said memory arenas.
Sorry for my.
Yeah, we have arenas. I'm familiar with that.
Okay.
How that works.
Yeah, I don't. The Perl source code is vast, and we each know. We each know part of it. Each of us is trying to describe one side of the elephant.
Thank you.
Other questions? If not, what I'll then do is I'll reshare my slides and in the remaining few minutes, I just want to mention some other topics that could be discussed with respect to QA. First of all, our basic tool for bisecting changes in the code base.
You're not sharing your slides. You're sharing a different browser.
What?
2 minutes, Jim.
Is that, are you
Yes.
seeing my slides now?
Yep.
Okay, so we have this tool porting bisect.pl, which is basically a wrapper around get bisect. And its documentation, curiously enough, is found in this program called bisectrunner.pl. In the last year, we added many more examples to this program. So it's a lot be easier for newcomers to the core distribution to use. There are people among the porters who do a lot of fuzzing, which means they throw a lot of random input at a program and see what breaks. In fact, over the last several years, fuzzing has generated more bug tickets than any other technique that we use. And it's very important for detecting security flaws. However, it's way out of my area of expertise, so I'll pass on describing it further. In the last year, particularly since we moved to GitHub for issues and for our repository, we have more centralized QA continuous integration tools. Centralized in the sense that they're directly configured by the core maintainers in the core distribution, and they run on our repository. So this includes Travis, that many of you are familiar with, GitHub Actions, and for more discussion of that, I'll recommend you to this 4 p.m. EDT talk by Mark Fowler and Olaf Alders. We also have non-centralized QA tools that we've been using for some time, the smoke testing rigs, like testsmoke.org, smoke aggregators. These are largely volunteer maintained. And one of the difficulties that we, of course, have in doing that is that if a volunteer goes away, we might lose one source of important information. What will happen in Perl 7 for our QA processes? I don't know yet. That's to be determined. And with that, that's my presentation for today.